Hi guys and girls. So today we're going to talk a little bit about a couple more tests using antibodies. The first is going to be the Ouchterlony. So that's the one over here. So Ouchterlony double diffusion test. So it's a pretty simple test. So it uses agarose. So I use. So remember, agarose works as kind of like a molecular sieve. So things can diffuse through it or pass through it, but it slows them down based on the percentage. So I can put it in a petri dish. I can make an agarose, maybe a 1% agarose. So the way it's done is in the center here, I put antibody. And in the outside circles, I put antigens. So the antibodies will diffuse outwards from the center, and so will the antigens, right? And where they meet, so if an antibody meets an antigen it wants to bind to, it causes a precipitate. So this is a precipitate line. So the precipitate line indicates a positive reaction. All right. So there's different ways to evaluate. So if you look at the top test, right? So if I look at this test right here, you'll notice that this has anti-O is ovule, right? So they're looking at eggs. So ovule, and then the compound is N, right? So they'll put two N's here, right? And they'll put the antigen for anti-N there. So when it diffuses out and the N diffuses toward it, it makes that that kind of shape there. And that shape is indicative of a positive result, right? So if I put my ends here and I get a crisscross path like this, it means it's not a conclusive result. So it's a no result. It's creating a precipitate, but the precipitate doesn't really mean that it's anti-that. It just means it's precipitating, right? Because I get those crossed lines, right? If I get lines that are jagged like this, it means it's partial identity. It may be, so I have to test it again. Maybe I need to purify my my antibodies or my antigens, or rethink how I'm running the test. Okay, so if we look at the top situation, so the anti-N is definitely a positive. So in the second one over here, you look at anti-OR. So this was an inconclusive result because I've got a cross going this way, I've got a cross going this way, and a cross going that way. So that's a maybe, but it's also reacting with the N, right? So what they did was, for this study, they gave a different version of anti-R, and then they've got this pattern. So this is definitely a positive result. So they went back to the drawing board, and it's not reacting with N anymore. So N here would be your control. Up top, R here is your control. And then normal IgG, that's an IgG without anti-N or anti-R, right? So I get nothing. So that shows that it's another form of control up here, right? And then we get another anti-R up here, and I get that nice positive result there as well. Okay, so that's an example of the Ouchterlony double diffusion test. It's called double diffusion because it's diffusing from both. It's diffusing from both the antigen and the antibody. Okay. So Western blot. So if we remember, Southern is equal to DNA, named after Edward Southern, right? We had Northern equals RNA, and we have Western, which is equal to proteins. So we've talked a little bit about Southern blotting before, so we'll talk a little bit about Western blotting. Okay, So it works a lot the same way that Southern blotting does. First I'll run my proteins on page. Right, so I'm running them on a vertical system, right? So I'll run them on a page system. And when I get the gel out, I do membrane staining. So I got my gel. Remember, if I do SDS page, it coats my protein in negative charge, right? So I have my let me see. Nope, I've got it wrong here. So hold on. Let me fix my stuff. All right. So my gel is here. My polyacrylamide gel is here. And I know that because I have my negative charge on top. All right. So the important part here that shows up on tests. So this my nitrocellulose paper and other absorbent. Other absorbent material, right? So what'll happen is my negative charge will push proteins. It'll push proteins off of my gel in this direction, and those proteins will be absorbed. Right, so my nitrocellulose will absorb, and then the extra buffer will go into the absorbent material. Right. So if you look at this right here now, so I've got my nitrocellulose paper right here. Right, so that's my nitrocellulose paper. And I've got my proteins attached to it. And then I've got indirect ELISA. Okay, so I've got my antigen, I've got my primary antibody, I've got my secondary with HRP, and I got my TMB, and I'll get a color change, or I can use a fluorescent particle, and I can use fluorescence and spectrophotometry. So that's Western blotting. Important parts, you got to start out with an SDS page, right? I've got to orient it, right? This is also called electroplating sometimes. My gel toward my negative cathode to push my proteins onto my nitrocellulose paper, and then I can read them with indirect. So just because it shows up on this test again, we'll talk about Southern blotting. It's pretty much the same, right? So here I've got my horizontal gel, right? So I do my electrophoresis, and then I have the same thing, right? So here, I'll put my gel below. So, and then on top of it, I have my absorbent material. Right? And then with my absorbent material, they'll put a salt solution on top, and that salt solution, remember water follows salt, will draw the buffer up. When it draws the buffer up, my DNA is transferred, right, to my nitrocellulose paper, and then I can hybridize. So I'll with fluorescent probe, right? And then I'll do an autoradiograph, right? So I'll use X-ray film to get that fluorescent probe to heat up, and then I'll see what it is, right? So that was the old Southern blotting. Remember Southern blotting? They're saying RNA or DNA, if I remember. DNA is northern, or RNA is northern blotting. All right, short and quick. I hope you have a good week. I'll talk to you soon. Good luck. Bye.